Hi, everybody, and welcome to this small little seminar on traffic light systems. This is going to be a brief introduction brought to you by myself, Aaron Diaz. I am an engineering student at Liberty University. Let's go ahead and get started. From the beginning, traffic light signal systems started in about the 19th century in London. They literally had a little flicker of light, candle, wick light, and they would control the signals based off of just changing where the light would flow through each, the red, green, and yellow. By 1917, we saw police officer William Pott create his first switch operating system operated in Salt Lake City. By 1920, we saw a timer system become more effective in most intersections in the United States. Types of traffic light signals. In modern day, we can see two major types of intersections. The first is a timed light. Have you guys ever been sitting at an intersection and you're just patiently waiting? Nobody else is there, but you have to sit and wait at that red light? More than likely, you were sitting at a timed intersection. The way that system works, it times out. Uh, it'll time out each queued light and each area that get the next green light. Second, we have a controlled intersection. With a controlled unit intersection, it receives inputted information from sensors and cameras. I know we think a lot of those cameras are spying on us, but they're really not. Most of the time, they're there to receive inputted information to allow for a green light to be given at your intersection. Components of traffic signals. The very few basics everyone knows. There's more than likely a pole holding up a light that shows green, yellow, or amber, um, and then red. These will help indicate which direction the flow traffic will happen next. The direction options, pretty simple and straightforward as well. You have your left, right, and through. Uh, the system of a modern intersection also has a lot of technological components, such as a controller cabinet, which you can find right over here under this green box, and input system sensors such as the camera, the sensors, antennas, and different components of the intersection. It also contains internet lines and a VPN to come back to our traffic control centers that you can find over here. Let's take a look inside what a controller cabinet looks like. I know most of the time we drive past these, we don't even think twice about it, but they are very important to our everyday lives and the traffic flow as we drive on our roads. As you look up here, you will notice this is the controller unit with three inputted wires. This is where most of the signal and is better known as the brain of the system, where inputted information is taken in, is then goes through an coded algorithm, and an output is taken out so that it knows when to give a red or green light. Most of the time, this is just on a loop counter. Engineers engineering the system of a traffic signal. So we're going to go ahead and take a look at the simple intersection. Most intersections you're going to have a straight through, a left, and a right turn signals. A lot of the decisions engineers go through is identifying it through a ring barrier diagram. As you can see down here, you could see in ring 1 you got option 1, and ring 2 you have option 5. Looking over here at the intersection, this is the main road. This is a minor road. You will see that the left turns can go at the same time, and the same for 7 and 3 for your lefts. Then you got your throughputs on your main road and your throughputs on your right. Each time you see a barrier in this ring barrier diagram, that is going to be an all-way stop for a duration of time between 1 and 3 seconds. This is to allow for the intersection to clear, in case anybody, I'm sure you have, and I, have gone through a yellow light. Or, worse yet, you thought you could have fit through the intersection, but the light turned red. This 1 to 3 second grace period allows for an all-way stop and allows for traffic to keep flowing at a better pattern. Another system that is used most of the time and during most of the time today in intersections, you'll see images like this off to the side, where this is basically a view through the camera inputting information into our brain in the controller cabinet. You see these vehicles lined up right here. As they enter these boxed sections, now the brain of inside our controller cabinet can identify there's a vehicle there. I can begin a transition to allow this cued line to move forward with a green light. The older systems were time systems where traffic would be on set timers and would not be able to mitigate traffic that backs up during peak hours. Uh, we slowly switched from this and have become more accustomed to activated traffic light systems that are more for the modern day, where they can receive inputted information and allow for better traffic flow. Just a little bit of the math behind what happens and the algorithms that take place during and planning of a new traffic signal. As you see here, these are the many different variables. We've got the position of a vehicle, we got the speed of a vehicle, the duration of the vehicle waiting, we got signal light codes, we've got duration time, we've got lane density, how long that queue line might be. A lot of these things all come into factors. There's so many different variables. When planning a new intersection, there's plenty of math to be considered. A lot of data needs to be analyzed in order for traffic to flow smoothly. Challenges in the traffic signal management. A lot of the challenges are basically those variables that we pretty much discussed in the last slide. The time of lights to allow traffic to flow smoothly. You got pedestrians. You're not sure if they're taking too long to walk across the street. You're not sure if they're disregarding the signal and just going. That slows up your right turn lane, your right hand turn lanes. Accidents. We know that's the most popular place for a car accident to happen is these intersections. All this can create unknown variables that a system can't have inputted into it. So what might the future look like for traffic intersections? It's going to come down to adaptive signal control technology. A lot of the metropolitan areas are beginning to structure their light signals this way to allow for a network-wide connection. When you have a network-wide connection, you can have an algorithm that times out green lights to red lights. Even if those lights are back to back to back, it's going to time that out no matter what time of day it is. If you got peak hours, if you're in slow hours, or if you're back in the afternoon peak hours, you know that this network-wide system will be able to do the math, take the inputted information, and feed out to allow traffic to flow smoothly in our communities. This type of networking could easily transition the job function. Right now, a lot of this is taking place under a civil engineering job code. But as we become more network-wide and more advanced in our technology and creating stronger and stronger algorithms or codes for these network systems, this can easily become the future of a computer engineering job to maintain our traffic flows and safer community. That's all I have for today. If you have any questions, please let me know, and I'll be glad to answer them. Thank you for your time.